Hello, my name is Jose Herrera. I am from Team Group 9 with An Yonghan, Chung Cheo, and our project is parking detection. Here is the agenda of our presentation. I'll talk about motivation and goal of our project, the project procedures, technology used, model structure and training performance, training data source, the demo and results, plans for future work, obstacles faced and our solutions to them, and finally, the project roles and a review. So the main motivation for our project was that Korea currently has a lot of traffic problems with cars, especially when it comes to parking. And in areas with high population density, it may be difficult for drivers to secure parking spots. In Dankook University, for example, parking spots are often taken, so students and faculty members try to find parking elsewhere, or they will usually park in a line. For example, there is typically not enough parking space during peak hours, such as morning or lunchtime. So not everybody can park wherever they want. And in the case of when a car leaves, others cannot recognize that there is now a free parking space. So in other words, parking rotation does not happen smoothly. The main goal of our project was to help drivers who wish to use a specific parking area to secure a parking spot or to immediately recognize and use empty spaces. A project that provides convenience to drivers, and this focuses on YOLO's version 8 object detection. It will also contribute to smooth parking rotation, and it can help disabled people guide them to parking spots and secure them parking spots. Here is a short list of the procedures of our project. We first started off with data collection, simple data collection, which that includes taking images and videos of parking lots, for example, our school or those found online. Then we would process that data into our YOLO model. We would, for the third of all, we would select a model, and that would include things like CNN for classification, and also including YOLO V8's model detection. We will, after that, proceed with model learning. Once that was figured out, we would evaluate our model. And after evaluation, we would focus on how we can improve our current model. And after all of our work was done, we would focus on the service and app development, which was the final stages of our project. As I mentioned before, some of the technologies that we used was YOLO V8, Python, and personal data acquired from taking photos and videos around our campus, Dankook University, and various parking lots. We also took data from online sources, and we used GitHub, and you can find more of our technical abilities and our code in GitHub. If you want a more technical details on that. Here is the model structure. And to summarize, we basically take an input, which is the images and videos collected. And we will receive an output after all of that processing, which would give us images of the parking lot with binding boxes and labels. Here's our model training performance. And as you can see at the top, we would have our first training model, which did not receive as good results as our last training model. And it would mainly be due to only using online sources for our first training model. And then for our final training model, which improved greatly from the first one, we use both custom data and online data. Now here is an example of what I mean by our custom training data source, where we took many pictures and videos of various parking locations from different angles in Dankook University, as you can see. And here's our online training data source. And we use the website Universe RoboFlow. And as you can see, there's also many examples and images of parking spots from various places. Now here is an example of our model. To summarize what this is, we have a red bounding box, and that signifies an empty or available parking spot. And the green bounding box will signify an occupied parking spot. And as you can see on the top right, it has a counter on how many parking spots are available or taken. We also have labels for every car. And now I will proceed with our video demonstration of this. Here's a live performance of our demo. As you can see, it has no issues with other objects such as people are passing by, and it detects the cars passing by as well. And here you can saw that the box went from green to red because a car had left. And as you can see, it's pretty accurate. Another car, that box turned red as well. I am going to put this into 10 speed just to finish off. And now we have available 3 spots, and 11 are occupied. And this example is in Dankook University. Your car is entering, so now you'll see that it will change to available 2, and now 12 are occupied, and then left again, and it changed again. And you see everything seems to work fine. Here we have another car entering. So the available spot should change to 1. Okay. Now I'll proceed to our second video demonstration. This is from a different parking spot and from a different angle as well. We only have 12 spots and 1 for disabled people. As you can see, it's detecting other cars that are passing by. And that would also became unavailable. Now I will fast forward this. Okay, now you should have an idea of what our project is, and I will proceed. Now, how we can further improve this project would be to provide information on vehicle contact and property accidents. We could classify them by large, medium, and compact vehicles, or other customized information. We could also improve it by having it help disabled people find parking spots and secure them parking spots. A further improvement would be to have a warning notification with parking in a no parking area. Also for navigating electric vehicle and rechargeable parking spots and notifying the remaining time of the vehicle that's being charged. Now, while working on our project, we did face some obstacles. Here is when we were gathering our own parking lot data. It was very tough, and because there were usually not enough vehicle movement, and it was tough to get our good camera angles, as you can see from these pictures. They are not the best angles. and it makes it hard to test. So just from this, it was very hard for our project to work because of the data that we gathered. Some other issues we faced was that the issue was faced with issues with counting the amount of available and unavailable spaces. Here we have incorrect labeling at times as well, as you can see where it says empty, it's also green. And we had issues with the dimensions of the parking spots for yellow. As you can see from the bottom, it's bigger or smaller than it should be. But we did have solutions to this. We spent a lot of time gathering data and trying different angles from recording at our school. And here, as you can see, these images are much better than the ones we took last time. So now you can see that the cars are actually being labeled properly. And also we made various modifications to our source code. But you can find more of this information on our GitHub. And what each of our members contributed to was for myself was the PowerPoint creation, presentation, and application development. For Younghan was that he collected data and a lot of the pre-processing. For Che, it was in charge of the learning and modularizing of YOLO models. And here's our review of the project. And thank you.